Welcome to today's presentation, Using InSpec with Cisco iOS devices, bringing a DevOps approach to network device compliance. Let's go ahead and get started. Julian, why don't you kick us off by telling our audience what we'll be covering here today?
Everybody, thank you very much for that introduction, Jamie. So as Jamie mentioned, my name is Julian Dunn, and I'm Director of Product Marketing here at Chef. And I'm joined today by Jerry Aldrich, who's a software development engineer on InSpec. So back to the agenda. So again, today we're going to be covering InSpec and Cisco network devices. So first of all, I'm going to make sure that everybody understands what is InSpec, because that could be something that's new to folks, particularly if you're working in the network device area. Maybe that's not something that you've been exposed to. Then we're going to talk about some of the cloud and network compliance features in InSpec 2.0, on which some of this work is actually based. So some of this work that we did in the recent release of InSpec 2.0 actually opened up the work that we're showing off today. And then what we'll be talking about is actually the Cisco and InSpec integration that is the focus of this presentation. And then I'm going to turn this over to Jerry Aldrich, who's going to show you a little bit of the syntax and do a little bit of a recorded demo about some of the stuff. And then, of course, we'll be leaving plenty of time for Q&A. So let's start out and talk about InSpec, just to make sure that we've level set on exactly what that is. So the issue with security and compliance practices in the past is that you have three different groups that are generally responsible for a number of different aspects of security and compliance. One of those groups is, of course, the information security team. And what they do understand is, for example, threats. They're typically penetration testers, or they understand vulnerabilities and that sort of a thing. But what they're not is network administrators, systems administrators, developers, and that sort of a thing. Now, these security engineers typically are taking rules that they have created from perhaps regulatory compliance regimes or compliance officers within a company. Now, those compliance officers, what they're strong at is often they are lawyers or they are regulatory people, and they understand the overall risk profile of that company with respect to regimes that they're part of. But what they, again, don't understand is they're typically not technical people. What they won't understand is, again, systems or individual threat profiles or security rules or that sort of a thing. And then sort of on the third leg of this three-legged stool is you actually have the engineers that are responsible, perhaps such as yourselves, the folks that are on the call today, that are actually in charge of managing network equipment, computer systems, applications, and things like that. And these folks, you probably have a technical background if you fall into this camp. But again, you don't really understand overall sort of compliance profiles or the regulatory regimes. You're simply, you're responsible for making sure that the stuff that you're working on is actually compliant, but you're not going to be an expert in actually what are the rules that come down from regulatory bodies or your own internal security groups. So fundamentally, what InSpec is, it is a software product and it is an open source tool to help you bring these three groups together to provide what we call DevSecOps. But really, you can think of it also as kind of a communication tool to get everybody on the same page about what it actually means for us to be compliant and secure in our companies. Because prior to a tool like this, you would have had, many of you, and I certainly have had this personal experience in my previous career, where the information security or compliance policies are expressed in an English language. And English language, as you know, is extremely ambiguous. And so when you get large binders full of documents and spreadsheets, Word documents, and this sort of thing, that state things such as, well, your system should have a mandatory access control system installed and enabled. Well, first of all, what does that actually mean? Second of all, how do I actually implement that? If I am running, for example, Windows, it's going to be a lot different than if I'm running, let's say, SUSE Linux. Or if I'm running SUSE Linux, it's going to be a lot different than if I'm running Red Hat Linux. And so this sort of ambiguity just leads to a lot of disagreements between, again, those three groups that are involved in information security. And what those disagreements lead to is just operational sluggishness, because people are just arguing about whether or not we are compliant or not. And the issue with that sluggish speed is that then we don't check whether or not we're compliant frequently enough. And that, of course, opens up the possibility for us to have uncaught vulnerabilities or things that go out of compliance. And we just don't really know about it because we don't have a programmatic way to evaluate this stuff. Worse still, the issue is the impact of the actual development process and actually shipping features out to production. Because what we've observed prior to products like InSpec is that folks would only check for this sort of compliance at the very last minute before things actually go into a production environment. So you have developers and systems administrators working away and setting up new infrastructure, developing new applications, so on and so forth. And then right before they go to production, we go through an extremely heavyweight security review process. And if you've ever worked with information security or as an information security professional, you'll know that those folks are very short-staffed. They're completely overloaded with a lot of work. And usually what happens is the work product that the developers just finished goes into a waiting period. And this waiting period, and we've heard customers talk about this, can be months or even sometimes years for the security review process to happen. So not only does it slow down the actual software delivery process, but the security review often raises a lot of extra flags, things that they didn't incorporate into the development process around compliance. And usually those things then get sent right back to the beginning of that development process, because then they have to get fixed before things get pushed out into production. Anyway, it just slows down the whole process. Nobody's really happy. Everybody views the security team as sort of police officers that are coming down to crack down on things. And it just really is not, it's detrimental to the actual operation of the business. Using a language like InSpec and this sort of DevSecOps approach allows you to incorporate compliance rules directly into the development process. So putting them right on the developer's workstation, even in their test environments. And again, what we're not expecting developers to do is necessarily to be experts in these sorts of rules and regimes, but just to be able to run these sorts of rules when they're developing, so they're making sure that they're not opening up unnecessary security holes. It's a lot cheaper to catch these sorts of errors at the beginning of this process rather than much later in that process. And so what happens is then, instead of having a very heavyweight security review process before we go to production, kind of think of it as being like a security inspection process, where information security now has a pretty lightweight and easy job, which is effectively to review the existing reports and the states of things that they already know. And effectively, this is just a sign off and making sure all the I's are dotted and the T's are crossed, right? Rather than needing to go and dig into every single angle and inspect things manually. Some of the customer benefits we've seen from this approach is helping organizations, of course, as I mentioned before, instead of checking for compliance only when they're delivering software or only when auditors are in the building and breathing down people's necks, you can now check for compliance at any time during your regular operations. You can check for compliance every 5 or 15 minutes if you want to. There are many customers that are doing this today. Of course, not only checking for this compliance status, but also the ability to detect and fix those security issues, again, long before they become audit findings, long before they reach production. This is a huge benefit. Not only are there many financial penalties sometimes for being non-compliant, but it also just allows you to deliver software faster. And that's really what we're really trying to do. Reduce risk, ongoing risk, but also the ability to deliver applications faster. So, for example, we have a customer that works in the healthcare services space, and they showed us this graph that they were using this to talk about this approach to their compliance folks and saying, look, when there's an audit cycle that happens quarterly, they're able to satisfy those audit requests about 95% faster because they're already collecting that data. They already have a historical record of that data. And so if the auditor comes along and says, show me this particular system or these sets of systems and how it's compliant today, they immediately can just pull up that data and then demonstrate that the audit request is green and the auditor can then move on. We have a partner of Chef's, NIU Solutions, which again have similar findings. They work with a lot of banking, financial services, customers, healthcare, and this kind of a thing. You can imagine those are extremely heavily regulated regimes. And they've also been able to find that by implementing this kind of approach, they've been able to reduce audit times for go live and also ongoing audits by about 93%. So similar kinds of ROI on this sort of a DevSecOps approach. So just a little bit of terminology before we get into some of the more technical elements of this presentation. There's really only 4 pieces of terminology that you need to know when we get to the point where Jerry's going to be showing off some of the code and doing some of the demos. So that thing, the little code snippet that I showed you before, that's testing for mandatory access control system being SD Linux and whether or not it's enabled. So again, that's what we call a compliance control. So that's a single test, a single compliance test that's expressed in this InSpec language. And of course, what you would do in a real production environment is you would then attach metadata to this particular control to control it for severity, because not everything is necessarily a finding where you want to set off all the alarm bells in the building. Some of them are just more discretionary, or maybe in certain environments that's not as important as others. So you want to be able to tune the severity of some of these rules. The other thing that you want to do is to add descriptive metadata to these rules. And the purpose of that is, again, sometimes these rules might be related to regulatory regimes. So you want to put in, well, this is related to PCI section, whatever, or SOX section, whatever. But it also allows you to provide descriptive information, maybe to inform a system administrator how they would actually go about in fixing this. What does this control being triggered actually mean, and so on and so forth. So then if we sort of walk up a little bit in the hierarchy of these objects, so you have these controls, which are basically individual tests of things for compliance on the system. So you would have many, many of these tests for the systems that you're running. And a way to bundle these tests together, these controls together, is what we call a compliance profile. It's a package of controls. You can take a package of these controls and evaluate them against your system. So these packages or profiles would represent, for example, industry standard benchmarks, such as, like I mentioned, PCI DSS, the CIS benchmark, if you're in the government, the DISA STIGs, and so on and so forth, right? A variety of different regulatory regimes. But also, you as a customer you probably have some preferences in what we call sort of house rules for what you perceive to be compliance in your enterprise. And so you also have the ability to package up your own controls and your own preferences into your own profiles. And of course, there's some inheritance between these two. So for example, you can base your own house rules on a standard rule set like CIS, and we allow you to have that inheritance and do that in a really easy way. The third thing is the actual systems or things that you're going to be evaluating for compliance. And so these are things that we call nodes. So you've probably seen these before. These would be things like servers or network devices, as we're talking about today, or even containers, or even cloud infrastructure, like being able to interrogate a cloud provider's API. And that now starts to extend the concept of nodes into things that aren't necessarily servers, but you can imagine that you can maybe have security issues with things like your Amazon S3 buckets and your network configurations in Amazon or in the Azure cloud, or this sort of a thing. And then finally, the process of evaluating these profiles and checking for compliance against these nodes is what we call a job, or a scan job, effectively. And scan jobs generate reports. Reports are things that you potentially can look at for your own operational purposes. But these reports will be also things that maybe you would send to an auditor to show them how compliant you are, or we have ways of exporting that data into other systems for compliance, such as your GRC type of systems in your enterprise-wide governance. So just really briefly want to talk about InSpec 2.0. InSpec is in its second major revision, of course, that we released earlier this year, on which a lot of this network device work is based. So previously in InSpec 1.0, what we had the ability to do is to apply this language to individual servers, machines that we had, either running on-premise or in the cloud. And what InSpec 2 provides and extends this the sort of language is into the ability to verify clouds. And things that you would verify in clouds are not only the machines that are in there, but for example, your networking configurations, right? Your Amazon security groups, let's say, or your routing tables, or your VPCs and this sort of a thing, or a lot of other things that you actually care about, like whether or not you have good security around your block storage, whether or not you have the right access management and identity management for your users, logs, and so on and so forth. A lot of things that you can check within the cloud. Now, I wanted to point this out because, really these two we launched with Amazon and Azure support, and these are sort of the two use cases that we saw most frequently out there. But you can imagine that this stuff is really built on sort of a generic framework of being able to interrogate things that aren't really just computer systems or servers, which is what brings us to talking about network device compliance today. Just want to give you a quick example of, again, what these rules might look like for something like a cloud environment. So perhaps you have some web servers or a web server running in an Azure environment. Be able to start describing and writing rules around your Azure virtual machine. Let's say we have this web server and we want to make sure that it's in the right Azure region, that it's got some description attached to it. So we don't want to have just machines hanging in space and nobody knows what they do. We want to make sure that it's got enough disk space to serve the web content and store logs and things like that. We want to make sure that the VM size is beefy enough to handle the traffic, and so on and so forth, right? All the elements of any kind of object within a cloud environment, you can now start writing rules to make sure that things are correct and proper. All right, so as I mentioned before, this sort of the features in InSpec 2 that allowed us to extend this sort of approach to DevSecOps from machines into other things also allowed us to do some of this work around extending compliance to network devices. So why do we engage in this work? What is so important about network devices? Well, what we have found and what industry research has found, particularly Gartner, this is a report that Gartner released a little bit earlier this year, which talks about the market for network automation activities. And the issue is that effectively network teams have often been a little bit slower than some of the other domain areas like systems administrators or developers in automating their work. And so this is a quote from Gartner, and Gartner says, network teams realize that they're often lagging behind these other domain groups in embracing automation to meet the growing business demand. And so what often you're doing is you're seeking to address this delta as quickly as possible, because what really sucks for the business is if an application developer or systems administrators have automated all the stuff around the network, and then they're still waiting for a network team to go and make changes manually or go and verify configurations manually. And so network teams are looking to automation to try and not be the blocker for a lot of these groups. And Gartner estimates approximately 10% or fewer of network teams are using any automation tools today. So congratulations if you're on this webinar. That means that there's lots of work for you folks to do, but you're definitely on the leading edge, and we definitely thank you for coming to this webinar and having and seeing our approach to network automation, because we think it's going to be really beneficial to adding business value for your company in the future. So just some common use cases for some of this network automation using InSpec with Cisco devices. So these would be things like, I showed you some of the CIS rules, CIS benchmark and things like this. So CIS is the Center for Internet Security, which publishes sort of best practices for, hey, how should you configure your servers, and how should you configure your clouds, and of course, how should you configure your Cisco network device equipment. So there's good practices for things like this. For example, it's 2018, let's not have Telnet turned on, let's make sure we're using secure protocols like SSH. So how do you know that's actually true if you're running a really, really large fleet of Cisco devices? This is something that you can use InSpec and these rules to go and validate. Another example is often SNMP is being used in the network world for reporting statistics and for interrogating network devices and managing them. What you don't want to be doing is using some older SNMP protocols, some of which are based on plain text or shared keys and things like this, or communities that are using common out-of-the-box strings. Like, you don't want to have an SNMP community that's called public, because everybody knows that that's kind of the default SNMP community. And if you have a SNMP community set to that, then everybody can start logging into your switch and doing things to it. Another thing is you want to make sure, for example, that you can gather the status of interfaces that you have on your equipment, right? Because one of the important things to do is, in good security practices, look, if nothing's connected to that switch port, we probably want to leave it turned off. We don't want to have, let's say, spanning tree or something turned on that port, because somebody could just come along. You're walking around the switch closet, just jack into your switch and then start sniffing traffic on your network or doing other stuff, right? So we want to make sure that, for example, things like ports where the link is down, that they're actually deactivated, that sort of a thing. And finally, there's lots of other generic things that you can test for with this kind of a language. So of course you should be able to test against the running configuration of your Cisco device and start examining it for a lot of different other elements. So we're launching this feature with support out of the box for Cisco IOS 12 and Cisco IOS 15. And of course, with your Chef Automate subscription is the CIS benchmark content for iOS 12 levels 1 and 2 and iOS 15 levels 1 and 2. And this content subscription really just lets you get started with the best practices for your for checking compliance for your devices. Because again, what you could do is you could just start writing all these rules yourself in this language. After all, the language is open source. But chances are you already have some internal regulatory regimes in mind. You already have some controls in mind. And so the value that we provide through the Automate subscription is just getting you started with these sorts of rules really, really quickly so you can get back to your job and actually using this technology rapidly. So with that, I'm going to turn this section over to Jerry Aldrich, who's my counterpart on the product engineering side, and he will walk through some examples and demo.
Oh, hi. Like Julian said, my name is Jerry, and I'm a developer on the InSpec team here at Chef. My goal here today is to give you a glimpse into what auditing your network devices might look like and to be available for questions if you have them. To start things off, let's cover a few examples of what Cisco IOS resources are available to you with InSpec. So out of the box, we support several Cisco IOS resources covering things from SNMP users, groups, and communities all the way down to individual interfaces. However, if you were stranded in a cold data center and you could only take 2 Cisco IOS resources with you, these 2 are your best choice. The first resource, Cisco IOS running config, is for making assertions on the entire running configuration. Usually this means you're verifying if a certain line exists or not. In this case, we are verifying if the running config has the line no IP HTTP server, which would indicate that the built-in web server has been disabled. The second resource, Cisco IOS command, is used to verify the output of arbitrary commands. In this example, we're verifying that the command show CDP has the output CDP is not enabled. These 2 resources will be your bread and butter of building compliance profiles for auditing your network infrastructure. Now, in addition to the bread and butter resources for command output and running config lines, you can also audit specific items. For example, we can check the names of all interfaces and verify that at least one of them matches the name loopback. So in the first example, it does just that. It will create a list of all interfaces that contain the word loopback in its name, then assert that that list should not be empty. If you wanted to verify the status and configuration of a single interface, the second example is what you would want. So here we're using Cisco IOS interface resource to check a specific interface, in this case, Fast Ethernet 00, and assert that its IP address is 10.2.3.1. In addition to interfaces, another subset of things you could audit with InSpec are SNMP users and groups, like we mentioned earlier. For example, the first test here creates a list of users using MD5 as their privacy protocol and asserts that that list should be empty. And the second example follows the same pattern, but asserts that no SNMP groups have a security model that is not v3 priv. So that will ensure that all SNMP groups are using the v3 priv security model. So you may be asking yourself, how can I get my hands on resources like these? And the answer is through our commercial product, Chef Automate. Like Julian was saying earlier, InSpec is an open source language, open source software. But when it comes to running InSpec across large fleets, that generates a large amount of data that you want to aggregate and share with other people. You'll also want to use this data to prioritize and fix compliance issues in your environment. Chef Automate's operational dashboards and rich query language provides its capabilities across all teams involved in compliance and security activities. And then you can also restrict access to sensitive data sets using Chef Automate's role-based access control system. Another benefit of Chef Automate subscription is that it provides access to premium contents and features, such as the Cisco IOS integration. Again, while InSpec the language is open source, customers want ready-made profiles that align to compliance rules they are familiar with. Chef Automate ships with dozens of CIS benchmark profiles, covering everything from Windows and Linux servers, Cisco iOS devices, and even cloud APIs like AWS and Azure. And finally, Chef Automate provides a built-in compliance scanner that allows both ad hoc and scheduled scans of your infrastructure. You can also give this ability to run these scans to compliance officers or security engineers so they can self-serve and answer questions about your infrastructure and its audit status without having to know the tools or run from the command line or anything like that. So with that out of the way, I'll show you how to use InSpec with Chef Automate. So there's a few ways to consume it. I mean, the Automate GUI is obviously one option, but you can also use the command line interface. So shown here is the command to log in to automate using the InSpec CLI. It takes a few arguments, mainly the automate server FQDN, a username, and a token created on the automate server. Once logged in, you can view the profiles available to your user using the InSpec compliance profile command. Shown here are the Cisco profiles I downloaded as the admin user. Then you can execute these profiles by running InSpec exec compliance : / your username and the profile you want to run. Then you pass in a target. In this case, we're using SSH with the demo user account, and we're targeting a device at the IP address 10.2.3.2. And then lastly, you can specify the password. Now, for the astute among you, you may have noticed there was a password specified on the command line in the previous slide, which is no bueno. If you'd like, you can move all of those command line arguments into a JSON file. And then you can also use this JSON file to define what kind of report you want to send to automate and all the things there to do it. So the token, the name of the node, stuff like that, even the environment it sits in. And then once you have this JSON file, of course, you can pass it in on the command line via the --JSON config option, or you can cat it in via standard in. For more examples on how to use this, I recommend reaching out to our docs site, docs.inspec.io. And here is an example of the output that you would get if you run this from the CLI. I mean, obviously, I've removed quite a few lines because it's 52 controls out of the box for the Cisco iOS 12 benchmark level 1 profile. But that's a general idea of what you'll see from the command line when you execute this. And then also, that will be sent up to the Chef Automate server. And here's what viewing that data on the Chef Automate server up in the GUI looks like. As you can see here, we have 4 total nodes, with one of them in the failed state. By clicking on the Nodes tab, we can investigate which node is failing. So in this case, 10.2.3.2, and we can investigate deeper. And then by digging deeper, we can see, just like we saw before, we have 52 controls, and one of those controls is failing. And then if we scroll down, or we can click on the filter up at the top, we can view the output of the test from InSpec. You can see here that we were expecting the command show CDP to have the output CDP is not enabled, or CDP is not enabled, but instead we got statistics of the CDP service, which tells us that CDP is running. And then also, in addition to the output, you can verify the source code used to run the test. So if you look carefully here, you can see we use the Cisco IOS command resource here. And with that out of the way, let's assume that I've fixed that node with SSH on the back end. And then I'm going to give a short demo on how to create a scan from the Automate GUI. So this is what you would see if you were a compliance officer or a security engineer. So here we go to the Scan Jobs tab. We'll create a new job. We can select the Nodes Manager. In this case, I've only got 4 nodes. And then you can specify nodes by name. So here I'm going to scan that one node that was failing earlier. Select the iOS profile, or the CIS profile that we want to run, in this case, iOS 12 benchmark level 1. Give it a name. You can also run these on a schedule. So you can say, hey, scan all of my iOS nodes every 5 minutes. And then that will kick off a scan job, and then InSpec runners in the background will run it. And I haven't doctored the video here. This is what a real-time scan of an iOS 12 device would look like for the CIS benchmark. And then once it's completed, we can look at the report, which will filter down to that one specific node. And then we can remove the filter and see that all of our nodes are now passing. So with that demo out of the way, I will open up the floor to the Q&A.
Very much, Jerry. So we have a couple of questions here. Why don't I just read them to you? And I think the answer to this first one is yes. The question about whether or not we can use InSpec with this integration to search for interfaces with a specific IP address. Maybe you can talk a little bit about how to do that.
Yep, absolutely. So the InSpec language is the same for all resources. The iOS interface CIS command resource is what we call a plural resource. So if we go back to that other example, you saw there was a .where, and you could specify a filter. So you could say Cisco IO interfaces, Cisco iOS interfaces .where IP address matches this regex, or IP address equals this. And then you can make special assertions on its status, like whether the link protocol's up, whether like the MTU is set like you would expect.
That's what I thought. And then we also had another question, which is we have a mix of other Cisco devices. We've got iOS, NXOS, iOS XR, so on and so forth. And does InSpec support this mix of images, or what does the roadmap look like for additional device support?
Yeah, I can't quote too much on the roadmap. We wanted to tackle iOS first, since iOS is traditionally the most difficult. The older servers, or the older devices like that, have some special ways that SSH is implemented. So iOS is definitely supported. And then with the Nexus stuff and devices going further, those should be easier to add support to because of how the SSH server is implemented. But I can't speak directly to the roadmap.
Great. And one more question, which is, can we do things like finding certain MAC addresses in ARP tables using this language?
I'm thinking, I don't remember adding a resource for that specifically, but if you remember back to the original example I gave, you can run any iOS command and check the output of it. So in theory, the answer is yes. Out of the box with the resources we support, it may not be the most ideal, but that is absolutely something that I'm looking for feedback just out in the environment. So if you've got I would like a resource that looks like this and does these things, feel free to reach out to me after the webinar and we'll get you the contact info, because I'd be interested in adding it.
Great. Okay, well, I think that brings us to the end of the Q&A section. So I just wanted to mention that, where you can get Chef Automate, chef.io/automate, and you can sign up for, I think it's a 45 or 60-day trial, which you can evaluate some of the stuff and the product contains. The content contains all the Cisco iOS scanning capabilities and so on and so forth. So with that, thanks for joining us, and I'm going to turn it back over to Jamie to close things out.
Thanks, Jillian. Thanks to Jerry for the demo, and thank you to our audience for the Q&A for the questions. As a reminder, a copy of today's slide deck and additional help materials are available in the resource list widget at the bottom of your screen. And a copy of this recording will be available by tomorrow. We'll go ahead and email you as soon as it's available. Thanks again for your time, and we hope you have a wonderful day.